All right, welcome back. We are GDD403, problem solving with data structures and algorithms in the winter 2023 semester at Canadore. And it says week 2, but actually we're week 4 technically of our broadcast and recording. This is part 1. We'll take a couple of breaks throughout the time here. And just want to welcome you back. I know that we don't have as many people on this week as we did last time, so hopefully they're going to either join or watch the video later. Before we begin, any questions or concerns from the last week? Anything that we had, left over from, the stuff we did last week at all? And if you don't have anything, that's fine. Thanks, Daniel. Excellent. All right, so I wanted just to kind of go through it. So this week we're talking about arrays and lists, and we're going to create a list of type game objects. We need to talk about a couple of updates too, because I was planning to have assignment 1 due by next week, but I'm going to move it out by 1 week. And the reason why is I had to get some assets for the in-class exercise today, as well as for the assignment. And I'm just going to push it out 1 week so we have enough time to get it done and to make sure that everything is in the clear in terms of what we want to do with it. All right, so last week what we did was we talked about kind of our course orientation, what's the course about, what are we learning this semester, and that kind of stuff. We also talked about algorithms, big O notation. We did a bit of a intro to collections a little bit last week, and then we did our in-class exercise where we talked about our tools installation. Hopefully you guys got that done, because you had to submit it for your in-class exercise. We're using Visual Studio 2022. Hopefully you guys have moved over to Visual Studio 2022 for this semester, as well as Git for Windows and setting up your GitHub account. Now, the in-class exercise that I had you guys do last time was you needed 3 things to get things done. You needed your GitHub link, which was private and had me as a collaborator. That's one thing you needed. You also needed a link to some kind of video resource, whether it was on YouTube or some other streaming provider. So that's the second thing. And in the video, you would show off your lab report and basically say, look, I did all these things. This is what I asked you to do. And then your lab report itself, which is basically just a checklist of the stuff that I wanted you to do for your in-class exercise. So those are the 3 things you kind of needed. Some of you didn't do all those things. And what I mean by that is some people didn't do the video, right? And some people didn't do the lab report, and some people didn't do the lab report in the video, which is what I asked you guys to do. So it's okay for the first one, but going forward for in-class exercise, I need those 3 things. They're mandatory. So I need a video. It's mandatory. You must make it. All right, it doesn't have to show your face, but you should have a title card with, hey, my name is, and this is what I'm doing, kind of stuff. That's what's part of the video. You must show your lab report, like in the video that basically shows kind of a checklist. And to get marks and stuff like this, right? And then you have to have a GitHub repository that you share with me as well. Those things are required. If you don't have some of those things, you're just going to lose marks, and I won't even mark your video, your lab, which is your in-class exercise, at all without a video. All right, so just letting you know, that means you're going to get 0 if you go forward without a video. You need to make that video, right? Because again, we're remote. This is one of our ways of maintaining academic integrity. You're going to be talking in the video, that kind of stuff, and describing the stuff. I need to hear you. And if you're one of those people, you forgot to upload your video last week and you had your video, but you just didn't give me the link, please let me know. I'll open up the Dropbox again and you can submit, okay? Or if somehow you forgot to submit your in-class exercise, I'll give you a chance to do it again, okay? But we need to get those things done because that's going to be the standard that we're going to use going forward for the rest of the semester. And on that, when we do assignments, you're also going to have to make an assignment video. The assignment will not require a lab report, but it will have a bit of a rubric about where you're going to get your marks from, right? And you're going to have to demonstrate stuff in your video for the assignment. So make sure you demonstrate all the tasks that I've asked you to complete. If I've asked you to create a class, which I'm going to ask you to do for your assignment number 1 or 2, a couple of classes, and I'm going to help you with that today. We're going to actually develop the card class today a little bit, which is part of your first assignment, right? And we're also going to do it visually in Unity. So remember, this is a game course. It's not just a course where we're going to learn how to be a banker or do, kind of manipulate code and then count. We don't care about that. What we want to do instead is we want to use Unity as a visual medium in order for you guys to, kind of have some kind of, context for the data structures we're making. So that's why we're using Unity and Visual Studio in combination. This course could run in another scenario if we're just doing software engineering, and that was all that it was, purely in Visual Studio with a console app. I just think that is too boring, and that's why we're doing it this way. Again, I'm reiterating some of the stuff so that you know what's happening and why we're doing the things that we're doing. Okay, so that is kind of a precursor to what I'm going to be talking about in a second, and let's get into this week's activities. So again, we're talking about this week about arrays and lists. ICE2 is a bit of a playing card simulation intro, which is going to help you with your assignment 1. Okay, so what I want to try and do with you is build some part of assignment 1 with you in the labs, right? There might be something that I need you to do, and that's why we're kind of building that up. And that's why I haven't released the details for assignment 1 yet, because I want to kind of see your capabilities in Unity and all that kind of stuff, and then give you a couple things to start off with, and then I'll release assignment 1 and say, I want these things, these tasks I want you to do. The assignment will be pretty detailed. I mean, it's going to tell you where you're going to get your marks, and there will be a visual and aesthetic component to it. So it's not going to just literally be coding. You need to do something in Unity, right? So just letting you know. I will provide some starter assets for you, but you may add other assets. I may ask you to add sounds and a bunch of other stuff to make it like a little simulation, right? We may do some of that in lab, in class exercise as well, right? And there might be some pieces that we won't be doing that you must do alone. Okay, that's kind of the assignment that we're going to be doing. So the assignment is largely going to be a playing card simulation that's going to help us, 3D, that's going to help us, kind of understand how to manipulate data structures and algorithms to do some sorting and searching and all those things. It makes sense because cards have a value, and then there is some kind of thing that allows to sort and search and shuffle and do all those kind of exercises with cards. Great thing is we'll be doing things with Unity, so we'll be doing some animations. We'll be doing some, like I said, some sounds. We'll have some assets that I'm going to share with you right now. On that, for in-class exercise 2, please take a look at the course shell that's on iLearn. And if you look at under week 4, you'll see that there is a GDD403 ICE2 starter. Please download that. We're going to start with that this week. And you please put that inside of your master repo for all of your in-class exercises. So that's another thing that happened. Some people just gave me one repository for the single in-class exercise. And what it's supposed to be is all of your in-class exercises in one repository, which means your in-class exercise should be a folder inside of your repo. And I'll show you that structure and how it should look in a second. So please download this starter and please make sure you can run it. Okay, so download, unpack it, and run it. Please do that now, because we're going to do kind of intercut between the two, and I'll come back to it in a second. Here's what your starter should look like now, okay? Like this. This is what your starter should look like. So it's giving you a bit of a card playing table that I've kind of put together for you, right? And it also has inside of it all the required materials for your cards. These are all the card materials that I've included for you. We still have the ground material from last week because that was kind of what we did. We may use it again, probably not, but I've left it in there. We also have the player material, which is just green, not really required. I do have the table material, which is the material that's going to be used for this table. Other things that are in the project as a starter, you're going to see card textures. So all the textures for the cards in basically a spreadsheet is what this is. The gravel cobble texture from last week, table textures, everything from your different ambient occlusion, the metallic, the normal map, as well as the regular diffuse, which we call shaders, or the textures for all of your materials. That's what's there. And then I've also included all the models, the default models for all your cards. So for example, the two of clubs card, you can see that the model is there. They're all the same model for the most part. And but I've also given you all the prefabs. So if you go to resources, prefabs, you'll see that all the cards are in prefab orders. So you'll see that club 2 is a 2 of clubs, club 4 is already there. They're all three-dimensional models, so 3D models that we can use. All of them have, just to go over it, all of them have a rigid body that has continuous collision detection and a box collider. So it allows you to drop cards on the table, no problem. Okay, so that's what it'll do. I've also included some extra cards, for example, the Joker, and some other things that you can see here in terms of some other cards. These are kind of separators a lot of times. And then under resources, also prefabs, there's also the table prefab. So if you wanted to recreate this scene or make another one, you can do it. And we may need to do this. I may add additional models and other things as we go on from week to week. So in-class exercise 2 includes all this stuff. Next week, we may include all of this and a lot more. And we're going to build up this project as we go so that it can be used for your assignment 1. Okay, that's what it's for. So for assignment 1, I don't expect you guys to get random models from other places to use in your assignment. I'm giving you the assets that you can start with, and so that it will alleviate your requirement from going in and grabbing or creating assets and putting them into the game. Okay. Questions around in-class exercise 2, and does it work for you? Can you confirm that it's all working? Please check this now.
I'm opening it up in Unity right now there. So far it's been working well. It's halfway done basically. So
okay, I just want to wait, because the reason why I want to wait, and when you're done, I'm going to come back to you guys. So I'm going to go on with the PowerPoint presentation, and then I'll come back and check to see that this is working, because without this, our in-class exercise today is going to be a little bit debunked, right? So, and defunct for the most part. All right, so let's get back to this. So that's our playing card simulation. It's kind of an intro to what we're going to be doing, for assignment 1. That's what's going to be happening. So we're going to do that. Again, assignment 1 has been updated. It's been moved to the week 6, so another week out, because we need more time. And assignment 2 also will not be released until that time, because I want to kind of, connect those 2 assignments together. All right. All right. So let's talk about some stuff that you guys should already know about. And my lecture is going to be a little bit smaller in terms of theory, and I want to move a lot more into practice with Unity and C#. Justin's asking, which version of Unity again? Yes, so it is 2022.2.1F1. This is the version that I want you guys to use. You can get that from the archive if it's not there. So remember, whenever you install stuff, if I was going to go to the Unity hub there, and if I was going to go to installs and click install editor, you can see that 2022.2.1F1 is not available anymore. We're at 5. We're not going to continue updating Unity to the next version, like I said. So you can go to the archive, and if you look at the download archive, then this is where you'll find 2022.2.1, this one. Okay, this is the version. So here, I'll give you the link for this to make it easier in the chat. Okay, that's the version that we're all using. And the reason for this, again, is so we're all on the same page. And, if there's a problem or some kind of bug that we're going to fix, then we'll fix it together. We'll all upgrade at the same time. All right, back to this. So, so I want to talk about some stuff that you should already know, like I said, which is arrays in lists. Now, this is not your first semester here at school, and you guys should know all about arrays and lists, but I want to talk about some stuff specifically with Unity, some stuff that works with Unity, some stuff that doesn't work with Unity. We'll talk about arrays and lists like you've never seen them before for a second, and it won't take that long. And then I'm going to get right into Unity and work with you in Unity the entire time, okay? Unity and C#. So let's do that. So what are arrays? We know that there are some kind of container that's going to contain data. In C++, arrays are contiguous, which means that they are set up so that when your data is next to itself, right? So every member variable, member of or element of the array is kind of set up, next to each other. And same thing with C#. The difference between C# arrays and C++ arrays, again, are C# arrays are managed in many ways. C++ arrays are very, very basic, right? And there's no management. You can use C++ arrays as a pointer. In C#, they're a reference type, right? Which is pretty cool. So you can, make a reference to the array as well. But they don't need a pointer. Of course, we don't use pointers in C# unless you want to. You can, if you really want to, in C# as well. You got to turn on the unsafe, unsafe code and all that kind of stuff. There's a switch to turn on, but you could do it. And they're part of, in C#, the system.array superclass. That's what they're part of, right? And which is an abstract base type. And that means that arrays can basically hold any kind of object, but they need to be the same object. The other thing we know about arrays is that they are immutable. Do we want to use pointers in C#? Yeah, the only reason why we'd want to use pointers in C# is if we're connecting to C++ somehow. So example, if you and I wrote a DLL, a library in C++ and attached it to Unity, and then C++ talks to C# somehow, that's the only time we want to use the pointer. And that even then, we probably can go without it, okay? But again, it's almost there's no reason to do it anymore. A lot of times people who are comfortable writing, using pointers and unsafe code, as an example, especially raw pointers in C++, they might want to use it in C# because they want to do something that they can't normally do. It solves a problem, something like that. But for the most part, yeah, I would agree with you, Justin. No reason. So one thing that arrays allow us to do out of the box is do sorting and searching. A lot of stuff that's built into C# is way more powerful out of the box for arrays than it is for C++. But that means also, when we think about it, that arrays structures in C# are fatter, have a heavier memory footprint than in C++. That's just the way it is, right? To some degree. Also, from a performance perspective, arrays are okay, but in many ways, when it comes to sorting and searching and all those kind of things, lists are actually very efficient in C#. And lists are not a linked list. That's a totally different thing, right? It's just I always think about lists like a managed array, even more managed than an array is. It gives you more things that you can do, a little bit fatter, but very efficient on the back end. I kind of compare lists in many ways in C# to vectors in C++. If I was going to program in C++, I might use the vector a lot in terms of creating a basic collection. And the difference between, again, arrays and lists, for the most part, is, well, there's a lot of differences, but the main one is arrays are immutable. It means once you make an array, it's set. That's the way it's going to be. You can't redimension an array so easily and all that kind of stuff in C#, especially not in C++. C++, as soon as you make an array a certain size, it stays that way, for the most part. And whereas a list or a vector in C++, they are mutable. They're dynamic. They can grow dynamically, and that's really powerful, and it's much easier for us to code with. But we also have to consider that typically arrays in C++ or even arrays in C# are smaller memory footprint because it's kind of a shorter class. As an example, a smaller set of specifications than the list or the vector list in C#, vector in C++. Again, with no relation to vector in Unity, it's just the name of the collection, the STL. All right, so that is a bit about arrays. So the other thing is that there is an array class, array list class. Array list is kind of, it gives you a little bit more than just a regular array. It dynamically grows, so it's not immutable, right? However, if I probably wouldn't use an array list in Unity, and can anyone tell me why I wouldn't use an array list in Unity. You guys know Unity enough to know why. Array in Unity, no problem. List in Unity, no problem. Array list in Unity, no. Why? Does anyone know? Well, here's the answer for me, right? When it comes to using too much information, no, it's not that. It's just that in Unity, remember, when we want to expose a public data member, and if it's a list or if it's an array, no problem. It'll actually show up in the inspector, but an array list will not. And so all the advantages that we would have gotten from an array list, which is in many ways a little bit more efficient than an array in terms of sorting and searching and doing all these other things, and growing in size and some things, the way the array list is created is not supported by Unity. So it won't actually be seen. You can't actually see your collection in the inspector. So I probably wouldn't use it. If I was going to kind of use an array list, I might want to just use a list. All right, that's what I'm saying. It just the trade-off, you're not getting enough performance out of it compared to what you would get from a list. Okay, just FYI. So that's kind of the thing that I would probably do. So again, I'm probably going to be either using an array or a list, and most likely for me, I always like to use lists as a collection because if they're dynamically growing, there's something that you can add, kind of elements as long as as large as you want. All right, so that's kind of the array list class. It exists. We have to talk about it, but it's not something that I need you to worry about this semester. Arrays or lists. That's it, not the array list, which is kind of weird. And also, array list is also another structure that exists in Java. So if you've ever taken Java or anything like that, then that is another structure there. And that takes the place of a typical list that we have in C#, which is just kind of the way it works. And remember, C# is Microsoft's answer to Java, the Java programming language, which has no relationship whatsoever with JavaScript. JavaScript is over here, and Java is more of I would say, the king of all languages when it comes to software engineering right now, more than C++, more than C#. If you wanted to get a job at a bank, Java is your friend, right? If you wanted to program in most, kind of enterprises, Java. They do a lot of work with Java. C# is less. C++ is even less. C++ is very small in terms of how many people use it. They use it for robotics. We use it for game dev, right? Some drivers that we're writing, and that's it, right? And maybe any kind of real-time, kind of computations. If I'm doing something with the stock market or if I'm doing networking, C++, right? If I'm doing, other functions, most other functions, Java, and some institutions use C#, especially things like some banks and some other, places like that, that have adopted the whole .NET framework, okay? So that's kind of the layout of things. And more C# is being adapted because adopted, I would say, because it is, easier to use in many ways than Java. It gives you the strength, almost the same level of control in many ways that C++ gives you. I can overload every operator in C#, just like I can do in C++, but in Java, I can't, right? In Java, there's a lot of stuff that I'm restricted to do. It's a very type safe and strict language compared to C#. So I think when Unity chose a scripting language, because that's what C# is for Unity, I think C# was the right choice, right? It's a higher level language than C++. C++ is, many times a dog's breakfast when it comes to trying to figure out memory management, pointers, and it's even the structure of a C++ program is something that, beginners have to figure out, how to build, how to link, all those kind of things. It's just another part of it, right? And I always liken it to this. When I talk to other students, I always say C++ is like looking at this massive board with switches and dials, and you have fully control, and you can, if you want to crash your plane, you can go ahead and crash your plane, no problem. C#, you have less switches and dials, almost the same power as C++, but it's got safety features. You can go on autopilot with C#. And Java, you've got a lot of features that are not there, but it's super safe. Like you can make, write a program in Java and not think too much, right? When it comes to, memory allocation, destructors, and all that stuff that you have to worry about in C#. Garbage collection is automatic in Java and in C#. You could do manual garbage collection in C# if you really wanted to. In C++, you need to do all that yourself. You need to do deletion. You have to do all the memory management yourself. So again, this is where array list came from. C#, again, was Microsoft's answer to Java when it first came out many years ago. And I think that's one of the reasons it solves some of the same things. If I want to write something in Java and I want to port it over to C#, array list might be the way I go. Okay, so that is that. Let's talk about array basics a little bit. We talked about different kinds of collections last week. Yes, that is true. You can crash everything in Java. You're right, but it really depends on your model and what application you're writing. But yeah, you're absolutely right. You can crash everything in C# too, which I just did yesterday as an example when I was writing a procedurally generated like sandbox. So again, let's talk about arrays a little bit more. They're basic objects, I would say at this point. We consider them indexed collections and they're sequential. We talked about different types of collections last week, sequential and non-sequential collections. We also talked about grouped collections, and hierarchical collections. This is kind of a review of some of the things we talked about last week. And arrays are sequential, so they go in sequence. They have every element in the array is like one after the other. There's zero index or zero-based counting we use for arrays because, again, it's a C influenced language, C#. So is C++. So is Java. So is JavaScript. So is TypeScript. So is many other languages out there. C is the kind of the father of all modern languages in many ways. So we know that. When it comes to declaring arrays, and some people don't know these things, so that's why I'm bringing them up. Certainly, you can declare an array like this, the type, and then so let's say, for example, string array is how you would do it, and then names, that's how you do it in C#. And then you would have to after you do this is just declaring the type. It's almost like I'm saying I need this kind of shape for my array. Okay, that's what I'm doing. But this, if I just did this, it wouldn't be enough. Okay, and the problem is that there is no container that's associated with the array. Remember that when we use a collection, an array, a list, stack, queue, whatever in the future we talk about, we need to instantiate the container itself, the box that everything is going to fit inside. And if we don't instantiate the container, then we're going to get kind of a null pointer error equivalent in C#, which is like a null reference is what it's going to be. And it's going to be like, hey, you know what? You're trying to allocate memory to something, a container that doesn't exist. That's what we will get. And you'll see we need to do this part. So this is the next part. So we declare here and we instantiate here. And of course, you can do it in one line, which saves us a lot of time, a one-liner. Sometimes, though, this is not, it doesn't make sense. And the reason why is because maybe we want to configure the size of my array later, but we want to declare the array earlier. And maybe the size of the array is going to be, the number of elements that we're going to use in the array, as an example, is something that we're going to calculate, compute the size of the array, as opposed to predetermine the size of the array, okay? So that's something that you can do. You kind of initialize 10 elements of type string. Each element is empty, so they don't have any value. So they have the empty value when you make in this particular case. And we allocate 10 members, and each of these members are, again, contiguous. They're right next to each other in terms of memory, right? That's how they work. There's another initialization syntax we can use, which is very similar to what we can do in C++. Actually, in many ways, it comes from C++. C# has adopted this thing where we can allocate an initialization list of elements as opposed to, kind of adding each element into the array one at a time. We can do something that looks like this. So we can say, let's suppose I want to make an integer array of numbers. I declare an empty container, but instead of allocating the number of the member size, then we just kind of declare that 1, 2, 3, 4, 5 would be the members. That's the values of each of the members in order. So that's 0, 1, 2, 3, 4 in terms of element index. And then we don't have to do this because the size of the array is inferred. Okay, so that means C# figures it out. That you need this many elements. But afterwards, after you add these things, you can't change the size of the array. It's just that way forever. Right? So it's good to initialize but it's not dynamic, okay? So that's one thing. Couple ways to do values or set the values of an array. You can definitely set it directly. And this is the way we would do it in other languages, in JavaScript, TypeScript, in Swift, in Kotlin, in every other kind of language you can think about. We do it like this a lot of times. Actually, in Swift, we don't quite do this. We append. But in object-oriented fashion, we can also do it this way, okay, where we set the value of an array with the set value method. That's part of the array superclass. All right. So again, not a lot of us don't do this, and you might say, well, you know, why would I want to do this when I can do it like this? A lot of times, and it really depends on your I would say your programming methodologies. I personally don't use this set value method. Sometimes it's helpful, right, and it solves some problems, but typically I don't. Right. And where this would be good is if you had an index and the value, and you were looping through in some kind of while loop or some kind of non-index loop, like a for each loop or something like that. And you wanted to specify or compute this number differently as opposed to using the for loop index iterator, right? So, but again, I probably would be able to do everything like this. I'm just pointing out that there's another way, and most people don't know that. Okay. Same thing with getting values. So in C# you can certainly return it this way. That's the classic way of doing it, the C style way of doing it. And there's also the object-oriented way of doing it, which is get value. So set value, get value. Okay. A lot of times when we want to initialize or access an array, we can do so in some kind of for loop, right? And you can use a method that's built into arrays called get upper bound, right? Which allows you to, to measure the size of the array. Sometimes, like it says here, beginners, what they do is they just hard code it. They say 5, right? Be careful when it comes to if you're removing elements from the array or something like that. And if you're doing something like removing elements from the array while you're looping, that's always bad. And especially since every time you come up here, you calculate get upper bounds or size count of a collection, anything like that, length, any of those kind of things, it's calculated, it's computed. It's not something that is happening once, right? So a smarter way of doing this, instead of doing it like this, would be to get the size of the array ahead of time, store it in another variable outside of the loop, right? And then use that variable, let's call it size, inside the loop itself, the loop signature, which is this part right here. And then it would say whatever I is less than or equal to size that we've defined outside the loop, that size variable is not going to change dynamically because it's just pointing to the value of what the array is. And as we loop, it's going to stay that value. Even if we remove elements from the array, we're just counting the next index, Careful about that when you're removing elements if you're counting at the same time, it's bad. Also, performance-wise, it's not great to do any kind of calculations in the header or the signature of a looping structure. It's not good. Okay, so don't do it that way. It's very common, but it's not something that you want to do. All right, things that we would get metadata from an array, the array class. Okay, so things like length, total number of elements in all dimensions of the array. Get length returns the number of elements in a specific dimension. When I say dimensions, if we have a multi-dimensional array, which again, you may decide not to do, right? And the reason why you wouldn't want to do a multi-dimensional array is it creates additional memory overhead, right? So even in C++, if you're making a multi-dimensional array, let's say you're representing a matrix or something like that, a lot of times we can do it with a single array, one single array, and then we can kind of access each of those members differently. So length, get length, rank, and get type, these are the very common ways of accessing metadata about the array. So example, rank is interesting because it returns the number of dimensions. So if I wanted to know if it's a multi-dimensional array, 2 dimensions, 1 dimension, 5 dimensions, then that's what we would do. Get type is the type of object that the array is holding, because remember, the array is a collection that holds the same type every single time. That's the thing that you have to do here. All right. Multi-dimensional arrays, great for matrices. Okay, so that's why we want to use them. And remember, in game dev, we use matrices all the time. The MVP matrix, model view projection matrix, which we want to use in OpenGL, and those kind of things for graphics. When we want to kind of get the we want to convert world space into iSpace and all kinds of other really interesting stuff. We use a matrix, and matrices are basically used everywhere in game dev. And so, yes, could you represent it with a multi-dimensional array? Yes, you could do that. Probably I wouldn't. I probably would make a matrix. If it didn't exist, I would make a matrix class of my own, or a struct, and then it would have the, do all the matrix calculations, matrix addition, matrix subtraction, matrix multiplication, all that kind of stuff. I'd probably do all those things in my own class if I was going to make a utility that's a matrix. Okay. But here, there's reasons sometimes it makes it easier sometimes when you're having a grid of some kind. And we use grids a lot of times in game dev as a division scheme. So example, we have a screen and we want to break it up into a grid. Let's say we want to do some kind of pathfinding in the future. Pathfinding is a little easier when we have to move from one part of the grid, one cell in the grid to the next. Right, we can calculate and we're going to talk about this later on in pathfinding, we can calculate the total cost for moving from one cell to the next cell of a grid. But first we got to subdivide the entire world into a grid, right? And matrices allow us to do this. Example would be something like the width and the depth in a three-dimensional world of the grid in the XZ plane, right? For example, in Unity. And then on the Y-axis, you could do a three-dimensional grid, and then you could use that in terms of kind of selecting a cell in a three-dimensional grid in some other place that you want to travel in 3 dimensions. So could you use a multi-dimensional array? Yes. Would I? Maybe not. It really depends on how I want to code it and how my mind is thinking in terms of how I'm going to iterate from one part of the grid to the next. It's certainly easier to do it this way. And when we think about what a multi-dimensional array is, it's like an array of arrays. That's what I kind of think about this. And it's almost like, because an array itself is an object, you can store the array inside the other one, and you can make an array of arrays. Would I want to do that? And that's the thing. It's more computationally expensive. It's more from a memory footprint. It's larger in terms of overhead. So I may not want to do it that way. I might represent a grid with a single array and just have an iteration method, something that's going to calculate the next, kind of the row, the column, kind of in the depth, let's say, or the height or whatever. It depends on how you're doing it. So certainly you can define the multi-dimensional array in rows and columns as an example. You could also declare it without telling C# how big it is, and then later on define it as a specific size. So you can use comma, comma, or comma itself. This would be a 2-dimensional array. This would be a 3-dimensional array. Okay. Again, we're just going over syntax, and I'm just trying to fill in any gaps you might have in terms of arrays. And I don't think there's going to be any, but I think we have to talk about it because some people are still, when it comes to programming, some people aren't that good at remembering this stuff if they don't need to use it. Okay, so that's why we're talking about it. So again, you can also use initialization syntax for initialization list for an array of arrays. And notice that we have an array on the outside. That's the curly braces on the outside. And then you have each member itself, each element of the outer array, right, has an inner array. A member itself is an array. So it's an array of arrays, which is exactly what we talked about, right? So this is the way you would initialize a grid of a 2-dimensional grid of values. Okay. Another reason why it's easier to do it this way in terms of the way we set things up is if I'm going to use some kind of tile map that I'm going to load, or I want to allocate a custom bitmap, and I want to make it so it's a kind of multi-dimensional array somehow. If you really want to do it, if it just from an ease of iteration perspective, this is why we'd want to use multi-dimensional array, but it's not as memory efficient. Okay. All right, so that is multi-dimensional arrays. When it comes to accessing multi-dimensional arrays, we could certainly get value the same way, but set value is not applicable. And the reason why set value is not applicable to multi-dimensional arrays is because it needs both a value and a single index, And because, unless you, again, create an extension method or something like that in C#, which you could. But the typical set value method that comes along with C# right now in this current form does not allow you to access multi-dimensional arrays, but yet get value does. So get value tells me I want the value at 0, 2, as an example. But set value only does setting a single value at a single location, so it doesn't work. So getting and setting values, as an example, is something that you want to do. All right, I have a duplicate slide. That's terrible. Tom, what were you thinking? Let's move on from multi-dimensional arrays and get into the C# collection framework really quickly, right? And again, this is just all an overview that I want to talk about with you before we get into Unity, so we understand. So C# is got a hierarchy, collection hierarchy, and it starts with this abstract collection type, a generic type, called I collection. I standing for interface, right? So I collection of type T. Now, did you guys do generics, or I'm hoping that you did generics and templates in C++? Yes? I'm hoping you got that done. Yeah, you should by now. Yes, no? Do you know what I'm talking about?
I don't remember explicitly there, but if I
Template classes, template classes in C++. So template type name, and then you put in the type of the template itself, and then you can make a very generic version of a method or a class that takes in any type. I'm so sorry about that. Yeah, so so if that's the case, Justin, then yeah, let's talk about this a little bit. When I talk about generics, let's go back. Ooh, okay, that makes a huge difference. You're going to see these angle brackets. Okay, so this is I'm glad we're talking about it then. Angle brackets looks like less than and greater than signs. Okay, we call them angle brackets. Anything in the angle brackets inside of that we declare with our next to the name of the collection. Example would be list, right? The stuff that's in the T represents the type. So example, if I want to make a list of type game object, then I'm going to say list, and in angle brackets, game object is going to be the type. And this allows some flexibility in terms of the type of list that I'm making, right? It kind of resizes or sets the memory footprint differently for that particular list or collection, right? So whenever we see like T in angle brackets, whether it's in C++ or whether it's in or whether it's in C#, it means it's a generic. And generic types are anything that I want to put in there. So if I want to put a string inside of a list, I can do that. If I want to put an integer inside of a list, I can do that. But we need to use that syntax. So whenever we declare a list, we need to say, I want to make a list of type game object. I want to make a list of type string. I want to make a list of type whatever, right? And that's how it works. So going back to that then, collection is the superclass. This is kind of the hierarchy of the C# collection framework that we're going to be using. And you can see that the kind of, I don't know if you can see this, but the darker, maybe light, there's some lighter areas and darker stuff. Anything that has an I in front of it is an interface. And the interfaces, what they are is, it's almost like actually, let me ask you this question. Do you guys know the difference between an interface and a class? Because if this hasn't been a programming heavy thing, then let's see if you know the difference. Interface and class, do you guys know the difference? What is an interface? Why do I need one? Why do I even bother? And there's also something different in C# and C++ compared to what an interface is. So for those people who haven't had a really strong programming background, an interface, right, is almost like a declaration, like a handshake that I'm making with my program. I'm kind of saying that any class that inherits from or implements the interface must have the methods that I list or I declare in my interface itself. And why would I do that? It's used for identification. One thing that we have in C++ is multiple inheritance. Multiple inheritance allows us to inherit from multiple sources, multiple classes, right? So I have a superclass, a parent class that I'm inheriting from, and I have another one in C++ that I want to inherit from as well. I can do that in C# and in Java and in JavaScript and in many other languages. Most languages do not allow multiple inheritance, but instead they have something called an interface. And interfaces allow us to identify an object, not just by the class that it's inheriting, but by the interface that it implements. Okay, I'm saying these words and we don't know what it is until we actually do it, but that's what a collection is. A collection of type T basically says, I want to make a collection. It's an interface that's going to declare a bunch of methods that all collections can overload, right? For example, I want to declare that all collections have the add method. All collections are going to have the remove method. All collections are going to have some kind of counting method. As an example, that counts the number of elements in the collection. And then if I implement, the interface of type collection in iList or iSet or iDictionary or stack, queue, and linked list, all of these things, including everything down here, is going to have those basic methods, because you need to have those methods. If I list a method, or if I declare a method in an interface, I must override that method in the subclass. Okay, I must override. That's the rules. Okay, so that's what this structure. If you look at this, it's kind of a hierarchy of how everything is laid out. So list then inherits from iList, and iList inherits from iCollection. That's how it goes, right? And you can see that there's set and hash set and dictionaries, which is interesting. You can see that a sorted list, a pre-sorted list is more of a high efficiency list that kind of works with key value pairs. A dictionary always works with key value pairs, right? And stacks and queues and linked lists, we're going to look at these as an example as we go throughout the course. Okay, so that is the C# collection framework. And this is a very kind of a high level overview of what it would look like. There's other things in here too we haven't talked about, probably won't, because that's outside the scope of this course. Let's get into the list class. So the list T class, remember where T can be replaced by any type that you want, string, game object, integer, Boolean, whatever, right? It provides methods to do things like searching and sorting and manipulating lists, right? The list class is the generic equivalent of the array list class. So to me, I would probably never use an array list class in C# because we have a list, which is in my view, just a better construct, right? It does implement the iList generic interface by using the array whose size is dynamically increased. So we don't have a limitation in terms of the collection is not immutable. We can mutate the collection. That's what it means. I can change it. Mutating means changing, right? And so that it's a very more powerful. Again, on the downside, disadvantages, a little bit of a heavier memory footprint, I would say, right? Whenever we use lists, then I get the full power of all the things that are part of a list, but then my memory footprint is bigger, and you can clearly see that because I implement iList, and then iList implements iCollection, and iCollection, kind of uses the the object superclass and so on. And there's many things up here at the top that list has like built in. It's huge, right? And on that, if you ever want to take a look at the Microsoft documentation for list, I recommend it. So if I did something like list, and if I said C#, if I search that up, you can see it's going to take me to a list of type T, right? And Microsoft has good, extensive documentation on everything. It says from an inheritance perspective, it inherits from object and list T, right? And there are a bunch of other operations that are derived from, but it implements, like it says, the iCollection and also iList. Let's go up one level to iList T. Okay, so iList T, you can see that iList T is an interface, right? That's what it is. And it declares some methods, add, clear, contains, and a bunch of some simple methods. These are some methods that it implements, right? And these methods must be overridden, right, in the subclass, which is going to be, in our case, the list subclass. That's what it is, right? And if we go one level higher, that it goes into the I collection superclass, right? So there's I collection, and I collection, right? It implements something called I enumerable. I'm going to come back to that in a second. So I collection, it is the superclass of iList, well, super interface of iList, and it's also the super interface of the list superclass, right? And if you look down here, I'm just going to zoom down because it gives you a lot of examples of code. You can see that it has more methods some methods that it overrides, right? Or that it declares, sorry, and some extension methods that it also lists as well. Okay, so you can convert it to an array. You can always do things these are all things that you can do as well with all objects that inherit from collection, which is pretty cool. And then further up the chain, that's not being shown here, is the I enumerable interface. I enumerable. So the I enumerable interface is kind of even higher up on the hierarchy than what was shown in our little diagram here. It's way up here, right? And I enumerable, what it does is it basically says that it exposes the enumerator, which supports a simple iteration over a collection of a specified type. So without having I enumerable, you can't iterate, which means you can't do a for loop or a for each loop or something like that. It won't work. So that all collections are iterable. You can actually kind of put it in a for loop or a for each loop or something like that. Some kind of looping structure, looping construct. That's what it does, right? So that is this class. And you can see that, so it implements I enumerable. That's what it does. And that's what this is. And then further up the chain, if you're going to look further up, is most likely the object class. Okay, so that's where it is, and it talks about some information about how to do that. I'm not going to go into the low-level details here, but it's really great because the I enumerable, again, it exposes the I enumerator, which allows you to, kind of iterate through from one to the other. So there's I enumerable and the I enumerable type T, and the I enumerable class itself. All right, which is kind of interesting. The interface. Okay. All right, so that's what this is, and why are we talking about this? Because you're going to be like, Tom, you're boring me. I don't really care about this kind of stuff. Well, you need to know some of this stuff because sometimes if I want to compare one thing to the other, we also might might need something to for our custom classes to be something like iComparable. iComparable is another interface that we would have to implement with our custom class if we're going to do that. If we're going to compare one thing to apples to apples, let's say I wanted to compare one card to another card. If I'm doing a card class, I may need to implement something called iComparable. We're going to get to that. Or if I want to sort something, I may need to implement iComparable. Okay, because we're going to compare the value of one thing compared to the value of something else. Okay, we're going to get to that. So you can see that there are other things that we're going to talk about, and then there's the I compare right here, and there's the I collection. Anytime we see I in the name of anything, we know it means interface. That is the naming convention that Microsoft uses for their interfaces. Anything that has I in front of it. Okay. Actually, most languages use the same thing, but let's continue. So that's what this is. And so then back to this, a list of type T. What we want to do is we want to talk about some basic methods. That's all I want to talk about so far, basic methods of lists. So all lists, because they inherit from the iList, they implement the iList interface, and in turn that implements the collection interface and so on. All lists have these methods that have been written for you to use. The add, we want to add an object to the list, we can do that. Remove, those are basic things. Contains, equals, get type. If you want to convert it to an array, very, very powerful. We can convert one thing to an array. And sometimes we can also go the other way with an array class. We can go an array to list. So you can go back and forth from an array to a list and so on. It's very powerful. And these are basic things that we're going to be using this semester, these methods on and off. Okay. Questions around arrays and lists. Did you learn something new that you didn't know? Maybe some of the words I used are not familiar, right? And if you're uncomfortable, it's okay, right? Because we're going to use these words, and hopefully you're going to get more comfortable with some of the stuff that we've talked about today. Okay, so lists, yay, really awesome. I'm going to stop recording this one now after I've talked about arrays and lists. That was kind of my preamble. And after this, we're going to get right into doing something way more interesting, which is working with Unity. All right, let's do that. So I'm going to stop recording now.